So before we actually give a definition for dot product, we're going to describe the words that we use to explain dot product. So first, what is a quantity? And a quantity is either a vector or a scalar. Question: what actually is a scalar? So a scalar is quantities that are fully described by a magnitude, or even more simply, it's just a numerical value, really. The next question also would be, what is a vector? So vectors are quantities that are fully described by both a magnitude and the direction. For example, 5 miles is a magnitude and west is a direction. If you put them together, you could say 5 miles west and you have a vector. So bearing those definitions, we can describe what is dot product, and that is dot product is a scalar function of two vectors equal to the product of their magnitudes and their angular relationship. And with that being said, we're going to move to the baseball example to visualize dot product.
In this example, we have a particle shown as a baseball. Our particle is being affected by two different forces, represented by two different vectors. Vector number 1 is pulling it 7 units in the direction of the positive x-axis and 7 units in the direction of the positive y-axis. The second vector pulls it 10 units towards the positive x and 4 units in the direction of the positive y. To get the dot product of two vectors, you simply multiply the x components of the vector 1 and 2, multiply the y components of vector 1 and 2, and then add both products. In this case, we'll end up with 7 times 10 plus 7 times 4, which will end up in 70 plus 28, and we'll get that the dot product of vector 1 and 2 equals to 9.
Let me take care.